let's find out how to add vectors in 2 dimensions. As a review, vector quantities have magnitudes, units, and directions. We can represent vectors as arrows, and if these vectors lie on a straight line when you combine them, they are categorized as one-dimensional vectors. On the other hand, vectors that lie on x and y axis or any two axes are two-dimensional vectors. But the idea on how to find the resultant vector is the same. That is by connecting the starting point of the first vector to the ending point of the last vector. Let's start analyzing vectors in 2 dimensions by looking at the motion of a boy who walked 10 meters to the east and climbed 5 meters north. The resultant vector traces the shortest possible distance between the starting point of the motion and to where it ends. Now look, upon combining the head and the tail of the 2 vectors, we notice an angle of 90 degrees. This calls for the entrance of the Pythagorean Theorem as it relates the 3 sides of a right triangle, just like the figure that we have right now. The Pythagorean Theorem will be used to solve for the magnitude of our resultant. The letter C, or the hypotenuse in the Pythagorean equation, is exactly the same as the resultant vector in our problem. So we can derive our equation from it. Now, substituting the given vectors to the Pythagorean equation, we see that the magnitude of the resultant is equal to 11.8 meters. The other thing that we need here is the direction. We are actually looking for the direction of the resultant, and if we plot our resultant into an x and y coordinate system, many will assume that the direction is northeast, which is only correct if the angle is 45 degrees. Now the question is, how do we compute for the angle? Well, we can use trigonometric ratios to solve for the angle and help us identify the proper direction of our resultant. Maybe you are familiar with the mnemonic SOHCAHTOA because we'll be using that. If you want to find this angle, we note that this is the hypotenuse, the longest side of the triangle, and this side is the opposite side of that angle, and this is the adjacent side. The SO in the SOHCAHTOA stands for sine theta is equal to the opposite side over the hypotenuse. The Ka in the SOHCAHTOA is cosine theta is equal to the adjacent side over the hypotenuse. And finally, the TOA is tangent theta is equal to the opposite side over the adjacent side. For this problem, and most of the time, we will be using the tangent function. And so, in our figure, 5 meters north is the opposite side of the angle that we are looking for, and 10 meters east is the adjacent side. Finding the angle, we write the tan inverse of the absolute value of the ratio of the 2 sides. This will give us an angle of 26.57 degrees. Therefore, the direction is not northeast. Instead, it's north of east, and that is completely different. And finally, our overall answer for the resultant vector is 11.18 meters, 26.57 degrees north of east. Now, I want to emphasize on how to obtain directions because this is where the confusions come from. The direction of our vector here actually can be written using this angle here, 90 minus 26.57, so this angle is 63.43. Now, if you want to use 63.43 as your angle, then the direction is east of north instead of north of east. I hope that is clear. But if not, let's say we have another vector here. If the angle is 45 degrees, then the direction is southeast. But if it's not 45 degrees and you considered this angle, then the direction is south of east. If you want to use the other angle, then the direction is east of south because from south, you are going towards the east. What if the vector is here? Considering this angle, the direction will be south of west. If from this angle, then it's west of south. How about if the vector is located here? Then north of west from this angle or west of north from this angle. I'm hoping that everything is clear now. If you want to find out how to solve for resultants of more than two vectors and with an angle that is not 90 degrees, then click the link in the description below for vector addition using component method. See you there and keep solving!